Okay, now let us see optimization word problem. It is one of the application of differential calculus. It's very interesting. The question says rectangular cake dish is made by cutting out squares from the corners of a 25 centimeter by 40 centimeter rectangle of tin plate and then folding the metal to form a container. So at the beginning it was just a plane. It was a tin plate. The length is given to us 40 centimeter and the width it was 25 centimeter. This is given to us. Now from each corner we have to cut out just square, which is each side, let's say it's xx, and then when we fold it, it will be converted to a container, rectangular container. This is going to be 40 minus 2x. This is the length, the new length. Why we say 2x? You know, from this side x, from the other side also x will be cut out. So originally the length was 40, so 40 minus 2x would be the new length of the box, and the width, it's going to be 25. 25 minus 2x, it's better. 25 minus 2x, again the same thing, you know, xx cut out. So let me write it here. The width will be 25 minus 2x, and the height, this is the height, just x. So to maximize the volume, what the question says, what size square must be cut out to produce the cake dish of a maximum volume? You know, volume is equal to length times width times height, which is, our length is 40 minus 2x and the width is 25 minus 2x and the height is x. Therefore the volume is purely a function of x, which is 40 minus 2x times 25x minus 2x squared. I can expand this x for in either of the two brackets just to make it two functions, because my next step, you know, it's derivative, because our focus is how to maximize the volume. Okay, what values of x has to be cut out from each corner, that's the main point. Therefore let's derive it. When you derive, we can apply product rule, because we have two functions here. The product rule says the derivative of f times g is the same as f derivative g plus f times g derivative. So I can consider this one as f, this one as g. So by the formula, f derivative first, that means the derivative of the first bracket is just negative 2. So negative 2 times the second bracket is 25x minus 2x squared plus the first bracket take as it is, 40 minus 2x. Then the second bracket, the derivative will be 25 minus 4x squared. Product rule is applied this time. Okay, the first bracket derivative with the constant 0 and negative 2x, here it is. Okay, now we have to expand and then we have to simplify this expression. So when we expand and simplify, it will give us 3x squared minus 65x plus 250. We have to make it equal to 0, because we have to solve the derivative. Okay, we need to factorize and we have to make 0 and get the zeros, and then write it as a product of linear factors, and then we are going to construct sign chart, and then we'll see the sign change. Anyways, when we expand and simplify it, let's forget equal to 0, just this will be the expression. Now let's try to factorize this quadratic expression. It will be 3x squared minus 65x plus 250 we have. So to factorize, we have to think of two number product. 3 times 250 will be 750, and the sum, it must be negative 65, you know, product and sum rule. Those numbers are negative 50 and negative 5. I mean negative 50 and negative 15. If you add it, it will be negative 65. If you multiply, you'll get that result. Therefore this will be 3x squared minus 15x minus 50x then plus 250 common. Now let's regroup. What's common here? It is 3x, so x minus 5 minus 50, then x minus 5. That means x minus 5 as a common. If you take out, what remain? 3x minus 50. So all this process is just to factorize. So what the 0 of the first bracket is x is equal to 5, and the second bracket is x is equal to 50 over 3. Therefore, we have to construct a sign chart. The number line from the two zeros, the smaller one is 5 and the larger one is 50 over 3. And the two factors are x minus 5 and 3x minus 50 we have. Therefore, this will be 0 here, less than negative, greater than positive, and this one is 0 here, less than negative and greater than positive. And then let's multiply. Negative times negative is positive. Here it's negative, here positive. Here are the zeros. Now let us see the sign change. The sign change from positive to negative, it is maximum because it looks like this one. From negative to positive, it will be minimum. So this is minimum. So where is the sign? Because we are asked to maximize the volume. The sign change from positive to negative up here it is. What is this point? Is 5. Therefore, our conclusion will be to maximize the volume, x is equal to 5 centimeter must be cut out from each side. So the original question, what size square must be cut out to produce the cake dish of maximum volume? It has to be 5 centimeter, because the sign change appear at 5, not at 50 over 3. 50 over 3 means, it's a decimal number actually. But 5 centimeter from each corner must be cut out to maximize our volume. So this is purely the application of derivative differential calculus, how to optimization problem. So if you like my video, if you like this question, my solving, my process, like and comment. Thank you so much.